It might sound surprising, but trees actually communicate with each other. This isn't some fantasy or stretch of the imagination, it's real and science backs it up. Trees, which we often think of as silent, isolated giants, are actually highly social beings, constantly talking to one another in ways that most of us wouldn't even notice. So let's dive into how trees communicate, why they do it, and why it's such a big deal for the environment. And one of the most fascinating discoveries in the past few decades is what scientists call the Wood Wide Web. Just like the internet connects people all over the world, trees are connected underground by networks of fungi. It's this underground system that helps trees share resources, send warnings, and support one another. You might have heard of mycorrhizal fungi. That's the key player here. These fungi form a network of tiny thread-like structures called mycelium that weave their way through the soil and connect to the roots of trees. This network is so vast and complex that it's sometimes referred to as the forest's communication system. Through this fungal web, trees can pass nutrients like carbon, nitrogen, and water to each other, especially when one tree is in need. Think of it like this. Imagine an older, stronger tree that's been around for decades. This tree has an extensive root system and plenty of access to sunlight, so it's thriving. Nearby, there's a smaller, younger sapling that's struggling to get enough nutrients because it's shaded by the taller trees. Through the mycorrhizal network, that older tree can actually share some of its nutrients with the sapling, helping it survive until it can reach the sunlight on its own. It's almost like a form of parental care in the plant world. In fact, researchers like Suzanne Simard, a forest ecologist, have shown that mother trees, those older, larger trees in a forest, are crucial in maintaining the health of the surrounding forest. These mother trees aren't just looking out for their own offspring, but also helping other nearby trees. It's a community effort which is quite different from the idea we usually have of nature being all about competition. But it's not just about sharing resources. Trees can also warn each other of danger. Let's say a tree is being attacked by insects. The leaves of that tree will start to produce certain chemicals to defend itself, like tannins, which make the leaves taste bitter or even toxic to the insects. At the same time, the tree will release volatile organic compounds, or VOCs, into the air. These VOCs act as a warning signal to neighboring trees, so the trees nearby, upon receiving this message, will start ramping up their own defenses, producing more of those bitter chemicals even before the insects arrive. This airborne warning system allows trees to prepare for an attack in advance, almost like soldiers gearing up for battle before the enemy hits. There's a great example of this in the African savanna with acacia trees. When giraffes start munching on the leaves of an acacia, the tree immediately releases VOCs that travel through the air to other acacia trees nearby. In response, these trees start producing more tannins, making their leaves bitter and less appetizing to the giraffes. So what do the giraffes do? They move on to trees farther away that haven't yet gotten the warning. It's like the trees are having a conversation, warning each other. Hey, the giraffes are coming. Better protect yourself. What's even more incredible is that trees don't just communicate through the air or underground. They also have their own version of electrical signaling. This might sound far-fetched, but trees actually transmit electrical signals through their tissues, much like a nervous system in animals. When a tree gets injured, for example, if a branch is broken or an insect bites into it, an electrical signal is sent from the damaged part of the tree to other parts. This triggers the tree to release chemicals that help it heal or protect itself from further damage. Although trees don't have brains or nerves like animals, they've evolved a system that allows them to coordinate responses across their entire structure. Roots also play a significant role in how trees interact with their environment. Through their roots, trees can release signaling chemicals that influence the behavior of other plants around them. Some trees use their roots to suppress the growth of nearby plants in a process called allelopathy. For example, walnut trees are known to release a chemical called juglone into the soil, which inhibits the growth of other plants around them. It's a way for the walnut tree to reduce competition for resources like water and nutrients. While this may sound aggressive, it's just another way trees have adapted to survive in competitive environments. Now, all of this communication between trees isn't just an interesting quirk of nature, it has significant ecological and environmental implications. For one, it helps forests remain resilient in the face of threats like drought, pests, or climate change. By sharing resources and information, trees can collectively withstand challenges that might wipe out individual trees on their own. This interconnectedness also plays a key role in forest recovery after disturbances like logging or wildfires. A healthy network of trees connected by mycorrhizal fungi can ensure that new growth has the support it needs to take root and thrive. This system of communication is also highly efficient. The way trees distribute resources is almost like a highly organized logistics network. Trees can detect which parts of the forest are lacking in certain nutrients or resources, and they will transfer what's needed to maintain the health of the entire ecosystem. It's like nature's version of an economy where there's a constant give and take to ensure survival. The mycorrhizal network helps distribute carbon, water, and nutrients where they are needed most. This natural engineering is incredibly sophisticated, and we're only just beginning to understand how important it is for the survival of entire ecosystems. Another important aspect to consider is that trees don't just help their own species, they support biodiversity. Forests are home to countless species of plants, animals, insects, and fungi, all of which rely on trees for shelter, food, and a stable environment. The communication systems in trees ensure that ecosystems remain balanced, which benefits not only the trees themselves, but also the entire network of life that depends on them. Without these natural communication systems, many of the world's forests wouldn't be nearly as resilient or productive as they are. If we think about this from a human perspective, it's kind of like how a community works best when its members look out for one another. A neighborhood where everyone shares resources, offers help when needed, and warns others of potential dangers is going to be a much stronger, more resilient place to live than one where everyone fends for themselves. Trees have evolved this sense of community over millions of years, and it's been crucial to their survival. In conclusion, trees do indeed communicate, and they do so in ways that are far more complex than most of us ever imagined. From underground fungal networks to airborne chemical signals and even electrical impulses, trees are constantly interacting with one another to share resources, warn of dangers, and maintain the health of their ecosystems. This communication is essential for the survival of forests and the countless species that depend on them, including us. It's a fascinating reminder that the natural world is far more interconnected and intelligent than we often give it credit for. So the next time you walk through a forest, take a moment to appreciate that the trees around you are not just standing still, they're engaging in a rich, vibrant dialogue that's crucial for the balance of life on Earth.